Okay, so 4.4 exponential and logarithmic equations, day 2. Really, this is going to be just part 2, and here we're looking at logarithmic equations. So a logarithmic equation is an equation containing a variable in a logarithmic expression. So examples of this would be like log base 5 of the quantity of x plus 7 equals 2, or the natural log of 5x equals 35. Okay, so some logarithmic equations can be expressed in the form log base b of m equals c. We can solve such equations by rewriting them in exponential form. So if we have that log base b of m equals c, we can rewrite it by doing our loop and swoop and rewriting it so it's m equals b to the c power. One of the things we have to be careful about with our logarithmic equations is that we always have to check our solution, because remember we cannot take log of a negative or 0. Okay, so if you would rather just go ahead and figure out what x cannot equal at the beginning, that's fine. I suggest you just always check. So, looking at this first one, log base 4 of the quantity x plus 3 equals 2. So we're going to loop and swoop. So we're going to take this base of 4, move it to the other side. So we have x plus 3 equals 4 to the second power. So on your homework, it's going to ask you to set it up, and that's going to be your setup. You're not going to simplify anything. Just leave it 4 squared. So now to solve that, simplify. So x plus 3 equals 4 squared is 16. Subtract the 3. X equals 13. Okay, so check. The key thing we want to check is our inside of our log. So we would have log base 4 of 13 plus 3. And 13 plus 3 is 16, which is positive, so we're good. Okay. Let's jump to the right and do C. So 3 natural log of 2x equals 12. So start off with getting your log by itself, either by doing the power rule. Here, I'm just going to divide by 3. It's easier. So we have the natural log of 2x equals 4. And then remember, the natural log is the same thing as log base e of 2x. And so we're going to take that e and we're going to swoop it to the other side. So we have 2x equals e to the 4th power. And then divide by 2. So x equals e to the 4th divided by 2. And if it asks you for a decimal, you would get 27.299. Oh, and so the nice thing on this one, since we're multiplying for the check, 27.299 times 2 is definitely not 0, and it's definitely not negative. The key thing to really check for is if you're adding or subtracting, making sure that you get that positive on the inside. So looking at B, log base 2 of x plus 20 equals 3. Loop and swoop. So x plus 20 equals 2 cubed. X plus 20 equals 8. X equals negative 12. So we have a negative number. So it's definitely a time where we want to make sure we check. So we have log base 2 of negative 12 plus 20 equals 3. Negative 12 plus 20 is 8. And so we're good to go. So x equals negative 12. All right, D, 4 times the natural log of 3x equals 8. So divide both sides by 4. So the natural log of 3x equals 2. We can rewrite the natural log, or just know that there's a base e here that we want to swoop over. So 3x equals e squared, and divide by 3. So x equals e squared over 3, which is approximately 2.463. And again, we're multiplying. 3 times 2.463 is definitely positive, so we're good to go. All right. So now, sometimes you're going to have to rewrite them using our properties of logarithms. So remember when we are adding two logs, or adding logarithms. Oops. We multiply insides. Okay, so if we have log of x plus log of x minus 3 equals 1, we can rewrite this as log of x times x minus 3 equals 1. Remember, when there is no base here, it's a 10. So we can swoop that to the other side. So if we distribute, we have x squared minus 3x equals 10. Since we have a quadratic, we want to set it equal to 0. We get x squared minus 3x minus 10 equals 0, and we're going to factor. So we're looking for our factors of negative 10. They equal negative 3, which would be negative 5 and 2. So x minus 5 times x plus 2 equals 0. So let's see here. If x minus 5 equals 0, x equals 5. And if x plus 2 equals 0, x equals negative 2. And then careful to make sure you check. So for our first one, we would have log of 5 plus log of 5 minus 3 equals 1. And 5 minus 3 is 2, which is positive, so that's good. And then our second one, log of negative 2. Well, right there, that's an issue. That does not exist, because we can't take the log of a negative number. All right, so if we look at B, we have log base 2 of x equals log base 2 of x minus 7. They're the same bases, so we can condense this to be log base 2 of x times x minus 7 equals 3. We're going to loop and swoop. And I'm going to also distribute. So we have x squared minus 7x equals 2 cubed. And 2 cubed is 8. And since we have a quadratic, we want to be equal to 0. So x squared minus 7x minus 8 equals 0. Our factors of negative 8, the add to be negative 7 would be negative 8 and 1. So this factors to be x minus 8 times x plus 1 equals 0. So x equals 8 and x equals negative 1. Here, if we plug in, x equals 8 will work. But if we plug in negative 1, we get log base 2 of negative 1, which does not exist. Okay, so then our other property with logarithms, similar to our exponential, was our one-to-one property. So if log base b of m equals log base b of n, then our insides can just equal each other. So we're going to try to write each of these to be a log equals a log, or a natural log equals a natural log. So if we look at A, we have the natural log of x plus 2 minus natural log of 4x plus 3 equals the natural log of 1 over x. So remember, when we're subtracting, it's the same thing as dividing. So we can rewrite the left-hand side as the natural log of x plus 2 over 4x plus 3. and that equals the natural log of 1 over x. So in order to be equal, the insides have to be the same. So x plus 2 over 4x plus 3 has to equal 1 over x. And then to solve, we're going to cross multiply. So we have x times x plus 2 equals 1 times 4x plus 3. That gives us x squared plus 2x, which equals 4x plus 3. Since we have a quadratic, we want to set everything equal to 0. So we get x squared minus 2x plus 3 equals 0. So we're looking for our factors of 3 that add to be negative 2. And oops, sorry, this should be a subtraction. Well, let's do negative 3. That works better. Which would give us negative 3 and positive 1. So we have x minus 3 times x plus 1 equals 0, which gives us x equals 3 and x equals negative 1. So if we check, we would have the natural log of 3 plus 2, that's good, that's 5, minus the natural log of 4 times 3 plus 3, which is good, that's 15, equals the natural log of 1/3. So that works. X equals 3 is possible. And then if we check negative 1, so the natural log of negative 1 plus 2, well, that equals 1, so that's fine, minus the natural log of 4 times negative 1 plus 3, which would be negative 4 plus 3, which is negative 1, which does not exist. All right. And our last one, so log of x plus 3 plus log of x minus 2 equals log of 14. So when we're adding, that means we're going to multiply. So we have log of x plus 3 times x minus 2 equals log of 14. So since we have log on both sides, those cancel. And we're going to FOIL this left-hand side. So we have x times x is x squared, x times negative 2 is negative 2x, 3 times x is 3x, and 3 times negative 2 is negative 6, which equals 14. So we have x squared plus 1x. I'm going to go ahead and subtract this 14, so we're equal to 0. So minus 20. And then factors of negative 20 that add to be 1 would be 5 and negative 4. So we get x plus 5 times x minus 4 equals 0. So we get x equals negative 5 and x equals 4. Well, if we check right off the bat, log of negative 5 plus 3, that does not exist. And then if we check 4, we get 4 plus 3, which is 7, and 4 minus 2, which is 2. So x equals 4 is our only solution.